Practice problems 12.5.2 on lines in 3 dimensions. This is practice problem number 12, and it gives us the equations of 2 lines in vector form, and it asks us, are these lines parallel, do they intersect, or neither? In a plane, 2 lines are either parallel or they intersect. There's no third option. However, in 3D space, the 2 lines could miss each other. Often they're called skew lines if they do that, although if they do miss each other but they're perpendicular to each other in terms of direction, we call those orthogonal lines. So we'll look at orthogonal and skew a little bit later. For right now, we just want to test whether they're parallel or whether they intersect. Well, testing parallel is pretty easy for a pair of lines. What we want to do is compare their direction vectors. If their direction vectors are multiples of each other, then they are parallel, because in essence that means they're pointing in the same or in opposite directions. However, 1, 1, 0 and 1, 4, 5 are not multiples of each other, so I can say definitively they are not parallel. Well, let's look and see whether they intersect or not. To do that, what I want to do is build and then set up their parametric equations so they're equal to each other. So in the x direction, the first equation would be 1 plus t. 1 plus, I'm going to make a dummy variable for it because the 2 t's don't have to be the same in order to form a point of intersection. They just have to form a point of intersection. And then I want to set that equal to the other one. It would be 0 plus t, so I'll call that b. So 1 plus a would have to be equal to b. In other words, a and b would have to form this relationship where a was 1 less than b in order for the x coordinates of these points to be at the same location. Let's do the same in the y direction. Y would give me 3 plus a. And that would have to be equal to 0 plus 4t. And then in the z direction, we'd have -1, and that'd be it. And that would have to be equal to 5t. And that's 5b. So that gives us a clue right here. In order for their z coordinates to match up, b has to be equal to -1/5. That's the only place where this line will intersect the z coordinate of the other line. So now that I know that b has to be -1/5, I can use, say, the top equation to figure out what a would have to be. So if b is -1/5, then 1 plus a would have to equal -1/5, or subtracting 1, which is 5/5, a would have to be -6/5. So now I know a and b in order for x and z to match up at the same location. Let's test and see if the y coordinate matches. Is 3 minus 6/5 equal to 4 times -1/5? Well, this side is going to be -4/5, and of course 3 is 15/5 minus 6/5. That's of course going to be 9/5, and 9/5 is not equal to -4/5. So that means while x and z will be the same coordinate at the point generated by b equals -1/5 and a equals -6/5, the y coordinate won't match up. And that means there's no other point of intersection that's likely, and that, therefore these lines don't intersect. So the answer is they're not parallel, they don't intersect. These 2 lines are neither. Now we could test further and see whether they were skew lines or orthogonal, but that goes a little bit beyond this question. We'll take a look at that later.